11a, we have a quadratic equation in terms of cos, and we need to solve for theta. So first of all, since it's a quadratic equation equal to 0, we're going to factor it. So here I've got my factor box, and we can factor this. We have a common factor of 2x along here, 3x along here, and then we're going to have plus 1 plus 1. So the factored form of this is going to be 3 cosine theta plus 1 and 2 cosine theta plus 1, and that's going to be equal to 0. Since it's equal to 0, we're going to treat each of these factors independently. So solving for this one here, we're going to end up with cosine theta is equal to negative 1 over 3. So we know this is going to be in quadrants 2 and 3. But since this is not an exact value, we're going to need our calculator to solve this. So when we undo this cosine, we're going to end up with 1.91 radians. So theta 1, this is from the calculator, is going to be 1.91 radians. And then the other angle is going to be from the symmetry 2 pi minus theta 1. And it's going to be in quadrant 3 as 4.37 radians. Okay, so theta 2 is 4.37 radians. And since we're being asked for all real numbers, okay, we need to understand that we have to know the period of this, or the repetitions here. So looking at the original function, we can see that there is no horizontal compression or expansion, so that the period is going to be equal to 2 pi. Since the period is equal to 2 pi, to show all the repetitions of these two primary solutions, we're going to do plus n2 pi plus n2 pi. And n is an integer. Okay, so there are all, we have two solutions, two primary solutions for cosine theta equals negative 1/3, and then we have all the repetitions that are going to be based on the period. We're then going to move on to the second factor here. So we have 2 cos theta plus 1 is equal to 0, so we're going to solve that as cos theta is equal to negative 1/2. Now this, because this is an exact value, we're going to do this as an exact value problem. So this is going to be, again, in quadrants 2 and, let me get rid of that. It's going to be in quadrants 2 and 3 as well. And since it's an exact value, we know that this is related to the 30-60 triangle. So it's going to be in these two positions here. So that first position, I'm going to call theta 1. In quadrant 2 is going to be 2 pi over 3. Well, that's 120 degrees. And the one in quadrant 3, we're going to be 4 pi over 3, which is 240 degrees. So those are our two primary solutions. Again, we have repetitions now, and those repetitions are going to be based on the period. And our period for this is going to be 2 pi as well. So we end up with plus n2 pi plus n2 pi. So when we do these problems, we want to first of all find the primary solutions. And if they are within a domain, we need to find the repetitions that end up in that domain. For this one here, if it's all real numbers, what we want to do is find the primary solutions and then use the period to get the repetitions, and we show the repetitions with this n2 pi.